Hello, can you guys hear and see? Thank you, Drake. I didn't know you spoke French. Amazing. The answers are above. Go ahead and get started correcting your assignment. We can discuss and then move on to the lesson. Let me take attendance. No, I am not talking right now. Well, now I am. Thank you for asking. Okay, questions? Questions on any of this business? 11 and 17. Alrighty. Oh, 17's a doozy for sure. 13, 11, 13, 17. Alright. Just 1 second. Alright, let's take a look at 11. Let me pull up the worksheet. So we have fourth root of 9g squared. This one always gets the kids. I've been using this problem for 3 years now. Okay, so we want to turn 9 into 3 squared. We want to turn all numbers into their smallest base form. So like if you have, like 2 to the 7th is 128, we want this expression instead. So 9 is 3 squared. So you get 4th root 3 squared g squared. Well, honestly, it's my fault for not mentioning this. So, um, previously we would be done because you can't take anything out, right? But if you express this in exponent form, 3 to the 2 fourths, g to the 2 fourths, doesn't 2 fourths simplify? So you get 3 to the 1 half, g to the 1 half. Or, equivalently, square root 3g. So I'm sorry, I realize now that I haven't covered this yet. So that's how you do it. 13. Let's take a look. Y to the negative 4/5 power. Well, that would be the same thing as 1 over the 5th root of y to the 4th. We need to rationalize this, right? So we will multiply by the 5th root of something. Whatever it is, we need to complete the 5th. So there's just one y missing. That's not bad. Whoops, that would not be squared. Y to the 1 power. And so on the top we get, that's the wrong green, but that's fine. 5th root y to the 1 power, divide by 5th root y to the 5th, that's just y. So that's how you do 13. Do you have a question, Dylan? Can we ask questions about the quiz? Yeah, of course. I don't think I've graded this section yet, though, so I apologize. But you can go ahead and ask a question for sure. What's your question? Number F. Letter F. F is actually a number in some bases, so let me pull that up too. Is this? This is gold. This is gold. So Rad Quiz gold. All right. I will come to your question after I do number 17. So let's do number 17 really quick. X to the 1/4 plus 2 divided by x to the 1/4 minus 2. Okay, so how do you do this problem? Well, I know how I do the problem, but I'm trying to figure out how I'm gonna tell you how you stumble upon this. This is a very hard problem that I would not have expected you to easily get. So, I mean, imagine if, for instance, you multiply by x to the... Well, I mean, let's just multiply by the conjugate, because that's probably something you would try, right? So let's go ahead and do that. Let's multiply by the conjugate. If you multiply by anything else, you'd see that it's not helpful. But if you multiply by the conjugate, let's go ahead and FOIL this. So first will give me square root x, because 1/4 plus 1/4 is 1/2. Inside gives me plus 2x to the 1/4. Outside gives me plus 2x to the 1/4. And last gives me plus 4. I'll divide by. First gives me x to the 1/2. Inside and outside cancel because of conjugate business. So I get this. And so this would simplify. I'm just going to simplify the numerator. X to the 1/2 plus 4x to the 1/4 plus 4. Divide by x to the 1/2 minus 4. Okay, well that didn't finish the problem, but it did bring us somewhere that's easier to navigate. What you need to do is multiply by the conjugate again. X to the 1, but this conjugate now. X to the 1/2 plus 4 divided by x to the 1/2 plus 4. So you distribute on the top. Would you like to see me do that? I don't really want to, but I can. And on the bottom you get x minus 16. Would you like to see me distribute on the top, or are you good? Okay, sweet. And then Dylan asked for number f. Let's take a gander. 4th root 5 over 9y cubed. So we have the 4th root of 5 divided by the 4th root of 9y cubed. We can proceed by leaving this as 9, but it's a really bad idea. So I'm going to go ahead and change it to 3 squared. So you get 4th root of 5 divided by 4th root of 3 squared y cubed. And so we need to rationalize the denominator. Multiply by the 4th root of something to fix this into a perfect 4th root. So I need 2 more 3's and 1 more y. And so finally I get 4th root of 5 times 3 squared, that's 45 y, divide by the 4th root of 3 to the 4th y to the 4th, so it's just 3y. There you go. Is that good, Dylan? It is 1 more y. I'll send you a picture, Dylan. Oh, you're good. You don't need a picture. Alright, let's get into it. Alright, so we have learned how to navigate all these radicals and everything. All that's left is equations and inequalities. It's the overarching theme of Algebra 2. Okay. We're giving you all the tools you'll ever need for the rest of your algebraic career. Oh, I just now noticed. So the reason on the past problem where you can't where you shouldn't keep it as 9y on the bottom, I don't remember what the problem is, but it's something like this. You can, but at the end, if you multiply it by 9 cubed, in the numerator you would end up with 4th root of 5 times 9 cubed, and this would simplify down. You would have to simplify this, which is pretty difficult and a lot more work than you need. So if you did that, if you just kept with 9 and didn't simplify at the end, you probably didn't lose, but maybe half a point. But always try and convert these to the smallest base you can. And then also somebody asked for 14, so let me do that really quick. Cool. Wonderful. Okay, so, and then 14 is 8th root 81 over 6th root 3. I like this problem. So let's see, 8th root 81 over 6th root of 3. So this is 3 to the 4th power. That's what you need to notice. It's the same thing we talked about earlier. You need to make them into the smallest base possible. Divide by 6th root 3 to the 1 power. And so you get 3 to the 4/8 divide by 3 to the 1/6. And so you do 3 to the 4/8 power minus 1/6. And you just find a common denominator and go ahead and get that. Yeah, Capel's correct. Mesa. Yeah, it's split by addition and subtraction, not multiplication. So hopefully this answers your question, Sophia. Cool. Okay, let's proceed. Okay, so these equations are not really too bad. So we are doing radical equations and inequalities. inequalities? Cool. Okay, let's look at our first example. I have square root x plus 2 plus 4 equals 7. So in general, we're going to want to isolate this square root. And the reason we want to do that is because then we will be able to square both sides, get the square root to go away. So let's go ahead and do that. If I want to isolate this, I need to subtract 4, so I get root x plus 2 equals 3. Here I will square both sides. If I square both sides, the left side is going to become x plus 2. If you square a square root, it's like they cancel. And I get x plus 2 equals 9, x equals 7 is what I get. Yeah, Dylan, are you on Chrome browser or are you using the app? You have to use the browser right now? Why? Got a loaner? You can download it. It wouldn't take 10 seconds. It won't let you download apps. Goodness. Um, did you try mobile? Did you try the mobile app? Well, you could pull up the mobile app and yeah, I see the dilemma. Yeah, I'll send a picture when I'm done, and then also, you can also probably listen and work along, and then I'll send a picture when I'm done, and then of course the lecture video. Okay, cool. So we solve this, and we get x equals 7. Okay, so there's a small problem with squaring both sides. It's not, it's kind of frowned upon in the world of math. And what can happen is that we can create solutions that don't really exist, and those are called extraneous solutions. So with these problems, we always need to check. Always. So I'm going to check 7 by putting it back into the original problem. So I do square root x plus 2, so that's square root 7 plus 2 plus 4 equals 7. Square root 9 plus 4 equals 7. Square root 9 is 3 plus 4 equals 7. So this is good. It does work out. Let me send her this picture. Alright, continuing onwards. Let's see. Let's try another one. Square root x minus 12. Cool. Messed up my settings there. So square root x minus 12 equals 2 minus square root x. Okay, well we can't isolate both square roots. I'll answer your question here in a second, Capel. So just isolate one square root. One of them already is isolated, that's good, and we can proceed with squaring both sides. It's a good question, Capel. Maybe, kind of, but it's not really worth the extra brain power because it's not too hard to check. But yes, there are considerations you can take. But I mean, even if you do know how to do it without allowing room for these extraneous solutions, it's not really worth your time. But awesome question. Okay, so I can go ahead and square both sides. Oh, so to square both sides is fine, as long as you check your answers at the end. So it's just a dangerous method, basically. It is not rigorous in kind. So here, x, the square root goes away. I'm left with x minus 12. And here, nice, Dylan, cool. So I will actually have to FOIL this, because if I'm going to square this, doesn't that actually mean that I'm multiplying it by itself? So I need to FOIL. So first gives me 4, outside gives me minus 2 root x, inside gives me minus 2 root x, and last gives me minus x squared. So let's go ahead and collect like terms. I get x minus 12 equals 4 minus 4 root x minus x squared. Give me 1 second. I want to make sure I didn't write down this problem wrong. Oh, well, I made a mistake. That's why. This would be minus x to the 1 power. It's square root x times square root x. So it's just x to the 1 power. Cool. That's better. So these x's go away. And let me go ahead and bring the 4 over. So this is negative 16 equals negative 4 root x. Let me go ahead and divide by negative 4. I get 4 equals square root x. So again, I can square both sides. We're going to have to do that. So x equals 16. Question mark? Right, we need to check. So let's check back to the original problem. So square root x minus 12, square root 16 minus 12 equals 2 minus root x. So that would be root 16. So square root 16 minus 12, square root 4 is 2 equals 2 minus 4. So 2 equals negative 2. So x does not equal 16. We have no solution here. This is our answer. This should be plus. Thank you. Because it's a negative times a negative. 2x. Oh, that answers Hugh's question as well. Yeah. Sorry, I just had like an aneurysm or something. So this is what happens when you square both sides, is you find a solution that works out in this manner. See, this has to do with all the funny business between principal roots and whatnot. So that's what's going on. Cool. Okay, let's try a couple. So I'm going to give you guys 2 to attempt. Guess I'll put them here. That's fine. So firstly, let's try 5 equals square root x minus 2 minus 1, and also square root x plus 15 equals 5 plus root x. Alright, go ahead and give those an attempt. So let me know when you finish, but also take your time. Anybody still working? Yes, capable, for sure. Give you guys about a minute more to wrap these up. Okay, as long as if you guys are all right, let's go ahead and continue. So let's try this first one. 5 equals square root x minus 2 minus 1. We want to isolate the square root, so I'll add 1. 6 equals root x minus 2. Square both sides. 36 equals x minus 2. X equals 38. Does it check? Does 5 equal square root 38 minus 2 minus 1? Well, that's 6 minus 1, so this works. Very nice. So x equals 38. Let's try the other one. So it's already isolated, so we're good. Just go ahead and square both sides. X plus 15. I need to FOIL this. So first gives me 25. Outside and inside together give me plus 10 root x. And last gives me plus x. No. Not unless there's multiple answers do you need this list. So again, these x's cancel out. That red is really hard to see on the magenta. These x's cancel out. With this kind of problem, it's always going to be like that. Let me subtract the 25, so I get negative 10 equals 10 root x, divide by 10. Square both sides, so 1 equals x, maybe? So let's plug it back into the yellow problem. Square root 16 is 4, equals 5 plus root 1. Doesn't work. No solution. And Also, you don't have to wait until it's completely isolated to square it. You can square it here, so you would get positive 100 equals 100x, so x equals 1. So you can save yourself a step or just divide by the 10. It's not a big deal. Okay, let's continue. I guess we'll go down this way. Kind of struggle keeping my work organized with this thing. Okay, so let's see. There's also another variety of these. Well, there's two more small varieties. So let's look at, I guess let's do this since it requires less space. Minus 4. So notice we're dealing with the cube root now. No big deal. Instead of cubing, we'll square it. So let me isolate this bit that's cube rooted. So I will add 4. So I get 4 equals 2 of these guys. Divide by 2. I will cube both sides. So if I'm going to cube both sides, on the left side, this cube root goes away. I'm just left with 6x minus 3 equals 2 cubed, which is 8. Add 3, so 6x equals 11. Divide by 6, x equals 11 sixths. And this does check out. 6 times 11 sixths is 11 minus 3. 8 cube root is 2. 2 times 2 is 4 minus 4 equals 0. Perfect. So this could be 5th root, 4th root, 7th root, anything. You deal with it the same way. You're going to isolate the guy that has the root, or the fractional exponent. Same story, right? And you're going to raise both sides to whatever power you need to cancel it out. Earlier it was square, and now it is cube root. Do you have a question, Cable? Fractions that don't work? Maybe. Always gotta check them. So, I was gonna say this, but I didn't want to confuse you. But if this is an odd root, this is like perfectly legal. These will always work. If it's an even root is when you need to check it. But instead, I would just say it's always check it because it's worth your time to check anyway. So if it's an odd root, this doesn't produce extraneous solutions because reasons. If it's an even root, why? So so this is cube root 6x minus 3. And the way to get rid of a cube root is to cube it. So if you see this step here, 6x minus 3 to the 1/3 to the 3rd power, when you exponentiate these guys, they multiply and become 1. So that's how that works. Good question, by the way. Awesome. So let us continue. Cool. Wonderful. Square root 16 plus x equals x plus 4. Already isolated, so we're ready to square. This is the problem. So I get 16 plus x equals x squared plus 8x plus 16. These cross out already. And so I get x squared plus 7x. Whoops. I get x squared plus 7x equals 0. How do I solve this for x? Well, it's actually a quadratic, right? And helpfully so, or unhelpfully so, there's no third term. But this is fine. We can factor out an x. So I get two possibilities for x. X can be -7 or 0. On the homework, it's certainly possible that there could be a term here. Like imagine if it were x squared plus 7x plus 12. And in this, you would just factor x plus 3, x plus 4. So no big deal. Okay, so now we need to check both of these to the original problem, which is square root 16 plus x equals x plus 4. 16 plus negative 7 is 9. That's 3 equals negative 7 plus 4. 3 equals negative 3. Not a chance. 0 square root 16 is 4 equals 0 plus 4. Yes, so 0 works. There's no rhyme or reason. It could be 0 solution, 1 solution, 2 solutions. So there's no pattern or anything. You just always have to check. Okay, cool. Let's consider an inequality. Yeah, for sure. He says please. Okay. Inequality, so we have 3 plus square root 5x minus 10 less than or equal to 8. Okay. So let's go ahead and just solve it as it sits. I'll subtract 3 less than or equal to 5. Square both sides. 5x minus 10 less than or equal to 25. I stopped computing for a minute. So 5x less than or equal to 15x less than or equal to 3. This is part of the answer. This is not the entire answer. Thirty-five and 7. Thank you. Okay, so this is part of the answer. So if you remember back to the rational inequalities, you'd have like 4 over x minus 2 plus 3 over x plus 1 equals greater than or equal to 18. You would solve it, and you would also need to consider division by 0, right? So remember that you'd have to consider division by 0. Well, there's nothing like that here, but there is something that we don't want to do, right? Because we are not talking about solving this across the complex numbers. We don't want imaginary numbers. If we don't want imaginary numbers, then the inside of this square root better be positive. So let's see. How do I want to write this carefully. So the inside of the square root must be positive. Can it be 0? It can be 0. That's fine. Square root 0 exists, so we actually say non-negative. Believe it or not, this is a word. Non-negative. It's N-N-N. Cool. So I will say 5x minus 10. I will restrict that so that it can be never negative, and I'll solve this other inequality. So 5x greater than or equal to 10, x greater than or equal to 2. So I have two inequalities, one from the plain Jane problem and one from restricting it such that I will never have square root of a negative number. And so I can just combine these. Let me check something really quick. Cool. For some reason I thought the book had a different answer. Okay. Why is it equal to 2? Can't x be 2? X can be 2. That's fine. If x is 2, that makes this inside 0, and we'd be square rooting 0, which is fine. We just can't square root a negative number. So we will combine these two inequalities. X less than or equal to 7, and also x greater than or equal to 2. This will always be and, because they must both be true. So we end up with the things that agree between these two, so 2 to 7. Here's our answer in yellow. The interval 2 to 7. Any questions on this? So to recap, we get two inequalities, one from solving the problem and one from restricting the root so that it can never be square rooting a negative number, and then you combine them, always using an and statement. Always and. That's correct, 2 less than equal to x less than or equal to 7, but I would like interval notation. Thank you. They are equivalent statements, but interval notation is so important moving forward in math that I just want you guys to be extremely comfortable with it. So thank you for asking. And isn't my interval wrong? These need to be square brackets. Awesome. So let's see. Square brackets, right? Because it's or equals. Okay, cool. Excellent. Let's see. I would like you guys to go ahead and try a problem. The and part. So, in order for this equation to be true, x has to be less than or equal to 7. That's just solving the inequality like an equation. But we also want this to never be square root of a negative number, because that's bad news bears. So, first of all, we need that, and to avoid complex numbers, imaginary numbers, we need this to also be true. So since these must simultaneously be true, it's and not or. Does that make sense, Sydney? Cool, wonderful. All right, so why don't you guys try square root 2x plus 2 plus 1 greater than or equal to 5. Worksheet, worksheet, worksheet. Let me know when you guys finish. I am Finnish. I thought you were Swedish. Racist. Yeah, it is possible that the answer could be no solution. Good question. Give me just 1 second. Putting the homework on the portal. Cool. Okay, let's take a look at this. I want to subtract 1, so greater than or equal to 4. I'll go ahead and square both sides. 2x plus 2 greater than or equal to 16. 2x greater than or equal to 14. X greater than or equal to 7. So that's what I get just from the inequality. Then furthermore, 2x plus 2, the inside of the radical has to be non-negative. So I get x greater than or equal to -1. So I want to combine these two on a number line. So I get x greater than or equal to -1 and x greater than or equal to 7. So if I need these both to be true, I need them to overlap. So they don't overlap until 7. So our proper answer here is 7, infinity. But yes, I do not change directions here. Good question. I'm not dividing by a negative number. Hard bracket. Thank you. Did that answer your question, Hugh? Are you sure? Let's see. You talking about this one, Hugh? I don't see anywhere where a sign is switched. Unless you're talking about this less than and that greater than. Okay. So this is the problem posed, right? So we solve it and we end up with x less than or equal to 7. And the fact that this is greater than is because of this rule. We want the inside of the square root to be non-negative. So the part where you're restricting what can be under the square root will always be greater than or equals to. But in the problem, the sign doesn't switch. These are two separate inequalities. Does that answer your question? Wonderful. Awesome. Cool. Any questions with this, y'all? Give me one moment. So this is gold. Today is the 7th. Cool. I want to show you one last thing. Square root 2x plus 5 minus square root 9 plus x greater than 0. And yes, Isabella, to answer your question again, I meant to show you an example. Remember, they're always going to be and statements. And imagine if you get something like this. That's going to be no solution. If you have x is less than or equal to -1 and x is greater than or equal to +2. What was the answer to the previous question? 7 to infinity. Cool. So, if I square both sides now, it's not going to help me. You would see that if you square both sides. But what I want to do is get both of these alone on each side. Now I can square both sides. So I get 2x plus 5 greater than 9 plus x, or x greater than 4. So that's my one inequality. And looking back at the original, I want to make sure that I never take the square root of a negative number. But there's actually two square roots. So I'm going to have two restricting inequalities. Firstly, 2x plus 5 greater than or equal to 0, and also 9 plus x greater than or equal to 0. So 2x greater than or equal to negative 5, x greater than or equal to negative 5 halves, and then x greater than or equal to negative 9. So we have three inequalities here. So let me construct my number line. Negative 9, negative 5 halves, and 4. So it's greater than or equal to both of these guys from the roots. And this is the answer we got. So what kind of numbers satisfy all three number lines? Well, it's everything from 4 onwards. And wouldn't this be an open dot? So we get 4 comma infinity. And on the previous example, I put a hard bracket on infinity. You never put a hard bracket on infinity. Sorry for the confusion. But the previous example, the answer was hard bracket 7 comma infinity soft bracket. Here's our answer here for this one. Any questions on this? These are not or statements. These are all and. Oh snap. Yeah. Good question. Always and. Always, 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 always. Always. I'll write it in red. Always and for these. Because they are things that must simultaneously be satisfied. Okay, with that being said, homework's on the portal. Enjoy it. Have a great day. And peace, y'all. Thank you.